Hello everyone and welcome to Aviation A to Z. Today we are going to learn about the aerofoil, or you can say airfoil. So let's get started. Do you know when there is a flat surface or a wooden plank placed perpendicular to the airflow will produce 100% drag? And a circular object spinning in clockwise or anti-clockwise direction will produce 50% drag. So we will discuss later about drag and lift. But for now, just remember, drag is resistance to the airflow and the lift is a force which supports the object in airflow. But there is another object which we call airfoil produce as much as 5 to 15% drag only and is very effective to be used to make an object fly, which we call an aircraft. The theory above mentioned is known as circulation theory, and based on this theory, scientists has come to the conclusion of making an aerofoil more streamlined and such that it will produce as less as drag possible and maximum lift. Now, after knowing circulation theory, the airfoils were made cambered and some were even covered on bottom. The shape was copied from the bird's wing. The major step in the aerofoil development was the Clerk Y airfoil, the standard aerofoil section through 1920s and into 1930s. The NACA, the ancestor of today's NASA, developed much more streamlined airfoil that allowed a smoother flow of air and greater lift with less amount of drag. As you know that there are 4 regions in aircraft can fly. A subsonic means the speed of aircraft less than speed of sound. Transonic means intermediate phase from subsonic to supersonic. Supersonic means speed of aircraft greater than speed of sound, and hypersonic means speed of aircraft greater than 5 times the speed of sound. When the aircraft speed reaches to the speed of sound, there is a formation of a shock wave above the wing, due to which the lift gets disturbed and drag increases. To overcome this difficulty, Lockheed Aircraft Manufacturer designed a supersonic airfoil with their maximum thickness about midway and their equal sharp leading edge and trailing edges. NASA also developed GAW1 and GAW2 low-speed airfoils, and these airfoils were developed for general aviation aircraft with higher L/D ratio, means increasing lift and decreased drag. There are many types of airfoils depending upon the application. Now you are aware about how aerofoils have revolutionized the aviation industry. We will go through the basic of it. First of all the aerofoils are majorly classified as symmetrical and asymmetrical airfoil. A symmetrical aerofoil is an aerofoil which have equal camber. Asymmetrical aerofoil is an aerofoil in which the upper camber and lower camber are different in shape and mean camber line and chord line does not coincide. To better understand the terms, we will go through the terminology of standard aerofoil. So, here you can see an extreme points, the leading edge and the trailing edge, through which the straight line passing, a chord line, and all the line here are imaginary line. Then we have a number 2 chord, which is the distance between a leading edge and a trailing edge. Then we have a number 3 mean camber line, which is passing through the center of an aerofoil, which divides aerofoil into upper half, or you can say upper surface and lower surface. Then we have a maximum camber, which is a divergence from chord line to the mean camber line. Then we have its location, which is approximately 2/3 of the leading edge. Then we have a maximum thickness, which is from upper surface to the lower surface. Then we have a location of a maximum thickness, which is 1/4 of the leading edge. Then we have a leading edge radius, which is used to determine the characteristics of an aerofoil or its thickness. So it varies widely from the aerofoil to aerofoil. So I think you got a better idea about basic terms of aerofoil. Moving on, we have 2 important terms, aspect ratio and the fineness ratio. Now, aspect ratio is the ratio of wingspan to the wing chord, or you can say S upon C or span square upon the surface area. We will discuss it later in detail in our next video. We have a fineness ratio. It is the ratio of length of an aerofoil to the breadth of an aerofoil, which is A upon B. So today we learned about the history of aerofoil, in which we learn about circulation theory. We also learn about the basic and major type of aerofoils. We learn about the basic terminology of an aerofoil and the other terminology as well. So it's a quiz time. You will get 5 seconds to answer each question. Number 1. The maximum divergence between the chord line and a mean camber line is known as maximum thickness, maximum camber, or maximum length. Question number 2. The ratio of length of an aerofoil to the breadth of an aerofoil is called aspect ratio, fineness ratio या mean ratio. Question number 3. The speed of an aircraft greater than the speed of sound is known as hypersonic, subsonic, supersonic or transonic. Number 4. The airfoil in which the upper camber and lower camber are same is known as asymmetrical, symmetrical or supercritical airfoil. So, how much you got correct answer? Comment below. So, I hope you have a A to Z idea about airfoil. And in our next video, we will discuss about the 4 forces on aircraft: lift, drag, thrust and weight. Share this video with your friends and colleagues and subscribe if you want to watch such videos. Click on a bell icon to get notifications. Check out our Instagram page for aviation stuff. And finally, keep watching Aviation A to Z.